We already have the video done.
Yeah.
So what I wanted you to do was to narrate it, because we've already got the whole thing done, and we could just put music over it, but I think it would be cooler if we actually verbalized it.
Yeah,
you know?
it'd be easier to explain it.
Right. So what we've got going on is the project. It's on graphing polynomials, and so what we're gonna have you do is we're gonna go through the steps of it.
Mm-hmm.
And we're just gonna have you explain it verbally. You're gonna explain what's going on the screen, stuff like that.
All right. So how do you graph polynomials?
Okay, so so for graphing polynomials, the first thing that you have to do is to find zeros.
What are you doing?
I'm just gonna watch.
Oh, okay.
So first what we've got to do is we've got to find the zero, which is just the x-intercept.
How do you find them?
Okay, so to find the x-intercepts, you have to find the zeros, take the pieces of each function, and then set them to 0. So for this problem, what we're going to do is set x minus 2 to 0. We're going to solve it, and we'll get 2. We'll do the same thing for the other pieces, and then we'll get -3 and 4. The reason that the zeros are important, it's where the points will be plotted on the x-axis. So the reason that we solved that was to get the points where it crosses the x-axis. So we're going to graph the solutions on the plane. So first we're going to graph 2 because that's the one that we found first, and then we're going to do the same thing with the other 2.
Okay, so what's next?
So after that, you got to find the multiplicities.
How do you find those?
To find the multiplicities, we have to think back to how we found the zeros first. So the zeros were -3 and then 2 and then 4. Since each of those values only occurs once, then the multiplicities will automatically equal 1. The reason that we need the multiplicity is that it tells us how the line behaves when we have to graph it. So if a point's multiplicity is even, then that means that the line will bounce off of the point. But if the multiplicity is odd, then it'll go through it.
So what do we do next?
So after we do that, we have to find the end behavior.
How would you do that?
So the end behavior is what dictates whether the line on the graph goes to a positive infinity or a negative infinity. To find that, we have to look at the leading coefficient. For our problem, it's 2. So because it's positive 2, that means it will go to a positive infinity.
Alright, so that's how you find the end behavior, but after you do that, you have to find the degree. To find the degree, we have to go back to the multiplicities. The multiplicity of all the zeros was 1 because they all appear once in the problem. We have to add all of them together, so for our case, that is 3. So 3 is an odd number. That means that the line will end on the opposite side than it started. If it was even, then it would mean it would end on the same side.
So, what's next?
So we're pretty much done. We just have to graph a line now.
Line.
Okay, now we're drawing a line. So since the multiplicities were all odd numbers, the line will go through each point rather than bounce off of it. Okay. Gloria, you've been acting really weird. Are you okay?
Peachy.
What's my middle name?
Samantha.
I'm gonna go get some air. Lydia, you should come with me.
Yeah, I think I'm it's getting really hot in
Yeah,
here, actually.
Yeah, we're gonna go.
Okay.
No, you're not.
What? Run.
Now it's your turn.